This is recording lesson number 3 on ecology for Tara Stout at Limestone Community High School. This lesson will be looking at matter and energy in ecosystems and how they cycle throughout an ecosystem. In this lesson, we will be talking about a food chain and food webs and how they are limited and how much energy will be transferred up each level. First of all, it's important to understand that a food chain is not just an endless step-by-step process. It is limited to 3 to 5 steps, and that's because there is energy that is lost at each step as the organism is pretty much just living. Here we say as heat or movement, but truthfully that's even as the organism is breathing, pumping blood, reproducing, hunting, anything like that can release energy. Within this section, we're also going to be talking about trophic levels, and I believe it was in lesson 2 we talked about how the word troph means energy or nutrition. So a trophic level refers to each feeding step of the food chain, and it shows you how the energy and the materials will go from one organism to another as the organisms consume one another. A food web will show all of the possible food chains in an ecosystem, and a food web is a lot more practical when you're thinking of different species relationships because it really shows all the interconnectedness in ecology. The ecological pyramid is a similar way to look at a food web, but in addition to looking at how the organisms consume one another, will show you that energy availability at each trophic level or each nutrition or energy level. At the bottom of the ecological pyramid will be the producers. Remember, a producer is also known as an autotroph. And autotrophs, remember, are organisms that can create their own food from sunlight or chemical energy. So these are usually going to be thought of as your plants that can do photosynthesis. Above the base of the pyramid are going to be your first order consumers, and these are going to be your herbivores or organisms that feed strictly on plants. The ultimate source of the energy for our Earth is the sun, and so that would make sense that the organisms at the bottom of an ecological pyramid would get their energy directly from the sun, and they're going to have the most available energy. Now, this percentage is going to be one that you'll need to know for the test. Only 10% of energy is transferred at each level. The rest is lost as the organism is just living, like I said, eating, hunting, heart beating, digesting, things like that. Now here on your note packet, we have a very, very basic ecological pyramid and food chain all in one. At the base, we have our autotroph that would have the most available energy. Mice would eat the plants, snakes would eat the mice, hawks eat the snakes, and then worms would be the type of heterotroph known as a decomposer. And remember, decomposers return dead energy and matter back into, or not energy, but dead matter back into the ecosystem. So when you are looking at this ecological pyramid and figuring out the math, let's say, for example, that the plants had 1,000 units, or we'll call them kilocalories. You don't need to know kilocalories for your test, but let's say that they had 1,000 kilocalories of energy. 10% of that would go up to the mice. So to figure out what 10% would be, is you take the decimal, which is assumed to be at the end, and you move it one spot. So the mouse or mice would then have 100 kilocalories. Again, there's our decimal. 10% would go up to the snakes, move it, so the snakes would have 10%. And then the hawks would get 10% of that, Move the decimal, so the hawks would only have 1 kilocal of energy. This is looking at a food web. So again, we are going to have our autotroph at the very bottom, organisms that receive their energy directly from the sun. And above that are going to be organisms that are herbivores, your first order consumers. And those are going to be herbivores. So they feed strictly on plants. Above the first order consumers are going to be some of your smaller carnivores and also some of your smaller omnivores usually. So you can see we have a spider, for an example, as a second order consumer. Obviously that's going to be carnivorous. Predaceous insects or predator insects, insectivorous birds, and then of course the toads. So these organisms are all called your second order consumers. And again, they are going to be your smaller carnivores and then your smaller omnivores. And in this food web at the top, we are going to have our third order consumers. And these are going to be your top predators in an ecosystem. So in this one we have a fox, hawks and owls, and snakes. And then here's another example of the ecological pyramid over here. I'm going to erase some of my scribbles. You have an ecological pyramid, and it again just looks at it puts into a picture representation how much is available. You can see this has a really good representation of how much actual energy is available at the producers or the autotrophs at the very bottom. It takes up a whole lot of the pyramid and goes a lot smaller as you move up. So if we start with 100% energy, go up from there 10% to 1 to 0.1%. And you will need to be able to calculate this on a test if given a certain value. So before we get to that, let's pretend we have our ecological pyramid and we have the algae at the bottom, and then we will have the, let's say, convict tangs. This is all coming from the movie. We'll feed on the algae, and then, oh, I don't know, maybe a lionfish. I don't even know if they eat convict tangs, but they do now. At the top, and there's really not a whole lot that eats a lionfish, so maybe that wasn't a good one to say. But let's just say that the algae, for example, had 8,246 kilocalories of energy, and I am just making that number off the top of my head. 10% of that moved up to convict tangs, and then 10% of that up to the lionfish. So go ahead and push pause now, please, and see if you can figure out how much would be available to the convict tangs and then the lionfish. And then, I don't know, maybe we'll put people up here and they eat lionfish sushi. So push pause and figure it out. Okay. So let's see if you got the same thing I did. If my decimal is after the 6, I'm going to move it one spot for the convict tangs. So the convict tangs would have 824.6 kilocalories of energy. Take that value, move the decimal one spot, so the lionfish would have 82.46 kilocalories of energy. And then maybe people eating the lionfish sushi, move it one spot, they would have 8.246 kilocalories of energy. So make sure that you understand that process for the test. And that is the end of lesson 3.